these notes are notes 3.1 and they're on graphs of reciprocal functions. And this lesson really is going to provide the foundation for everything that we need to know for this unit. So make sure you're paying really close attention, okay? So question number 1 says, given the function f of x equals 2 minus x, determine the domain, range, intercepts, intervals of positive and negativity, and intervals of increasing and decreasing values. So the first thing I'm going to do is I'm just going to go ahead and graph out my function. So this is my x-axis, my y-axis. I'm going to go by ones. So make sure that you have some type of a scale on your axis that's critical. And then when you're all set to do all of that, we can go ahead and graph out our function. Now our function here we know is going to be a linear function because it's in the format y equals mx plus b. I know my slope is 1, so I can say that m is 1. And I also know that my y-intercept, sorry, my slope is not 1, my slope is -1. And I also know my y-intercept is 2. So I'm going to go ahead and graph this out. It starts at 2 and then it goes down 1 over 1. Okay, so this is what my graph is going to look like. Well, now that I've done my graph right here, I can go ahead and connect my dots. And this is what my graph is going to look like. Make sure that you have some sort of a straight edge to use to connect your dots. Okay, and then make sure you also have arrows on the end of your line on both sides. So I'm just going to put arrows right here. So this right here is going to be my line. Okay, now that I've drawn my line right here, we know that this is f of x. So I can go ahead and find my domain. And if I look at my graph right here, x can be any value on my number line. So x can be any real number. Okay. If I want to look at my range, same thing. My y values are going from -infinity to +infinity. So I can say that my y values can be any real number as well. Okay. So I'm done with my domain, my range. My intercept, I want to find my x-intercept. Well, my x-intercept is right here. And I know my x-intercept is 2, 0. Okay, and my y-intercept is also right here, so I know it's going to be 0, 2. Okay, so I've finished up my intercepts. Now, where is my graph positive? Well, my graph is going to be positive anywhere from -infinity. All of this stuff right here is all positive until I hit my root. Okay, so that means that my graph is going to be positive from -infinity all the way to 2, and then it starts being negative right over here. So my graph will be negative from 2 all the way to infinity. Okay, and again, this is all review right now, but this is really going to help you out when we get to the reciprocal function, which we're going to do in part B. Okay, so now that I've done that, I need to figure out where my graph is increasing. Well, my graph is increasing nowhere because it has a negative slope and my slope is constant. So there is no interval of increasing. Okay, so we finished our positive and negative intervals. We finished our increasing intervals. Now, where's my graph decreasing? Well, it's decreasing everywhere. So we're going to say it's from -infinity to +infinity. Okay, so now question B says use your answers for part A to sketch the graph of the reciprocal function. Well, my reciprocal function then would be g of x, we're going to call it something different, so you can use any letter you want, is equal to 1 over 2 minus x. Now, one thing that we need to make a note of is that all our y values are the reciprocals, because we're doing the reciprocal function, are reciprocals of the y values of f of x. Okay, so what does this mean then for me? Well, for example, right here, my y value here is 2, so the reciprocal of that is going to be 1/2. So I know that if I were to graph out this function right here, I know that instead of having a 2 here, I would have a 1/2. And the reason why I would have a 1/2 is because 1/2 is the reciprocal of 2. So I have at least one of my coordinates, okay? I also know that I'm going to have a coordinate right here because this y value is 1 and the reciprocal of 1 is 1, okay? Now here, my y value is 0 and the reciprocal of 0 is undefined. So that means that it's going to be undefined everywhere along this line. So let's go ahead and draw out that line and show that that's where my graph is going to be undefined. Okay, so let's just go ahead and actually let's use the screen right here. So I know that my graph is going to be undefined everywhere over here, which should make sense to you because if we look at what we have going on over here, x cannot equal 2. That's my restriction right here. Okay? So essentially, wherever my root is, for my original function, my reciprocal function will have an asymptote there. Okay? So now that I figured that out, I also know right here that if this y value is -1, the reciprocal of -1 is -1. And here my y value is -2, so the reciprocal of -2 is -1/2. So I'm starting to get some points. Okay, so the next thing I'm going to do is I'm going to look at my positive and my negative intervals of my original function. Well, if I take, remember we're doing the reciprocals of the y values. So right here, in this area of my graph right here, all my y values are going to be positive, okay? Which means when I take the reciprocal of a positive number, I'm still going to have positive answers. So I know that my graph, my reciprocal function will be positive in the same section that my original graph was positive. Okay, and then if I take a look right here, all my y values here are negative. So when I take the reciprocal of a negative value, I still get a negative value. So I know in this section of my graph, my reciprocal function is going to be negative. Okay, so hopefully that makes sense too, because that's really important. Now, the next piece that I'm going to look at, and I'm going to erase these arrows right here so I don't get too confused by what's going on. The next thing that I'm going to look at is my increasing and decreasing intervals. So remember, if I take, I want you guys to notice something that's really important. If I have like the numbers 1, 2, 3, 4, if you notice, these values are increasing. So these are going up, right? When I take the reciprocal of these values, I end up getting still 1, then I get 1/2, I get 1/3, I get 1/4. So these values are decreasing. So when my original values are increasing, my reciprocals are decreasing. Now let's see if the same is true the opposite way. So if my original values are 1, 1/2, 1/3, 1/4, these are decreasing. So when I do my reciprocals, I'll end up getting 1. The reciprocal of 1/2 is 2. The reciprocal of 1/3 is 3. The reciprocal of 1/4 is 4. So these values are going to be increasing. So that means that if my original function is increasing, then my reciprocal function should decrease, as well as vice versa. So therefore, I can conclude that since it's decreasing everywhere, my new function is going to be increasing everywhere. So we're going to say it's increasing here, and it's increasing there. Okay? Make sure that you're stopping and pausing and rewinding and doing what you need to do to make sure you truly understand what I'm saying in this video. All right. So now that I figured out all of this information, it's so much easier for me to be able to graph out my reciprocal function. So I know that my graph here, again, is going to be positive and increasing. So therefore, it has to stay above my x-axis, and it has to go up. So that means that it's going to try really hard to touch my x-axis over here, but it just won't. and then it's going to increase, and since I have an asymptote here, it's going to try to approach infinity. So that's what one side of my graph is going to look like. Okay, now on the other side, I know it's negative and increasing, so I know it's going to be below the x-axis, and it's going to also be going up. So therefore, my graph has to look like this. So then this right here is going to be my reciprocal function. G of x equals 1 over x minus 2. Okay? So that's how the reciprocal function and the original function are related to each other. Now that we've figured out all of that information, I'm going to go ahead and figure out some key features of our reciprocal function. So we know that our domain can be any number according to this graph, except for x equals 2. Okay, so our domain is going to be x is an element of the reals, but x cannot equal 2. We already got that restriction down. Okay, now for the range, we know the range can be any value for y, except if you notice it didn't touch the x-axis, which means that y can't equal 0. And because it didn't touch the x-axis right here, that means that we can say that we have a horizontal asymptote at y equals 0. Okay, so right here, I'm going to say I have a horizontal asymptote right here. So that means right here we can say that y can be any value except for 0. And this should make sense to you because no value, remember, all the y values are reciprocals of f of x, and there is going to be no value that has a reciprocal of 0 unless it's undefined, which we don't have any undefined values in our original function. Okay, so therefore we have a vertical asymptote at x equals 2, and we have a horizontal asymptote at y equals 0. Okay, we know that our y-intercept is going to be the reciprocal of our original y-intercept. So if this was 2, then our y-intercept was at 1/2, which we already included in our graph. So it's 0, 1/2. There's no x-intercept because it won't touch the x-axis. Okay. Our positive and negative intervals are exactly the same. So in our original function, our positive interval was from -infinity to 2. So our positive interval for this is also -infinity to 2. And our negative interval is going to be from 2 to infinity. Okay? And then our increasing and decreasing intervals are going to be opposites of each other. So if our original function is never increasing, then our new function is always increasing. And if our original function is always decreasing, then our new function will never decrease. So we'll say NA. Okay, and that's how our original function and our reciprocal function can relate to each other, and we can use that to help us do our graphs. Okay, we'll look at question number 2 now. Oh, let's take a look at question number 2. Given the function f of x equals 9 minus x squared, we want to determine the range, the domain, the range, the intercepts, the intervals of positive and negative y values, and then our increasing and decreasing intervals. Same exact thing. So I'm going to go ahead and set up my graph. So I'm going to label my axes x and y, and I'm going to go up by ones again. So I've got my graph almost ready to go. So now we know that our original function here is a parabola, and we know it opens down because our a value is -1. So remember, in our parent function, our vertex is usually at 0, 0, right? So actually, what I'm going to do is I'm just going to draw in my parent function really quickly. So we know it's 0, 0, 1, 1, -1, 1, 2, 4. You don't have to draw in the parent function. I'm just doing this really quickly so that we can see how to get our transformed function. And then we've got 3, 9, and -3, 9. So when I do my parent function, I know that the vertex is at 0, 0. So to get this function, I would multiply my y value by -1, and then I would go up 9. So here's one of my points of my parent function. Here, I would multiply my y value by -1, so it brings me to -1, and then I would go up 9, so it would bring me up to here. Okay? For this value, 4, I'd multiply it by -1. It brings me down to -4, and then I would go up by 9, so it brings me up to 5. Okay, here I've got I've got 9, multiply that by -1, I get -9, go up 9, I end up getting 0. Okay, so I know that this is the right side of my graph, the other side of my graph is symmetrical, so I can go ahead and just graph out these points right here. I'm going to erase the points for my parent function, so that way I can just deal with my actual function that I have here. So let's go ahead and connect these dots, and this is my parabola from my original function that we have. So now I need to find the domain. Well, I know the domain is going to be all real numbers because my parabola can extend all the way across my number line from -infinity to +infinity. I know the range is going to be any value of y as long as it's less than or equal to my highest point, which occurs at 9. All right, so now my x-intercept, when I look at my x-intercept, I know that my x-intercepts will be at -3 and +3. So I've got -3, 0 and +3, 0. But let's talk about this algebraically. Why are my x-intercepts -3, 0 and +3, 0? In order to figure out my x-intercepts, I just replace f of x with 0. So I get 0 equals 9 minus x squared. So I get 0 equals, when I factor it, it's a difference of perfect squares. So I get 3 minus x times 3 plus x, which means x can be 3 and x can be -3. So that's how we get our x-intercepts that we got here, okay? My y-intercept will happen when x is 0, and I can look at my graph and I can see that my y-intercept is at 0, 9. Now, where is my graph going to be positive? Well, it's positive everywhere from -3 from my first root to my second root. So it's going to be positive from -3 to +3. Okay, where's my graph going to be negative? It's going to be negative everywhere before -3. So from -infinity to -3. And then everything after 3. So we're going to say including. So this is a union. I'm going to say it's from here, along this interval, as well as this interval of 3 to infinity. Okay. Then I want to know, well, where is my graph going to be increasing? Well, my graph is increasing everywhere until I get to my vertex, because my vertex is my maximum height right here. So I'm going to say that it's increasing from -infinity to 0. Okay, and then I can also say that my graph is decreasing after I reach my vertex. It's just going to keep going down, so it's decreasing from 0 to infinity. Okay, so now that we have all that information, we can go ahead and use that to help us figure out how to graph our reciprocal function, which is what question B says. Use your answers for part A to sketch the graph of the reciprocal function. So we know that our reciprocal function is going to be written as follows. So g of x is equal to 1 over 9 minus x squared. But one thing I want you guys to do is factor that denominator so we can kind of see it in two different ways. So I can also say it's 1 over 3 minus x times 3 plus x. Okay? All right, so now that we've done all of this information, we have to see how we can apply all of this info to get our reciprocal function. So if we know that we have an x-intercept at -3 and at +3 of our original function, then we know that the reciprocal, because the y value is 0, the reciprocal is 1 over 0 or undefined. We know that it can never touch -3 or +3. Okay, so we can go ahead and say that it'll never touch these values right here. And since it won't, that means that we actually end up getting two asymptotes. So let's go ahead and graph out where our two asymptotes are going to be, or two vertical asymptotes. So we know we have a vertical asymptote when x is -3, and we also know that we have another one when x is +3. And this is going to break up our graph for us so we can see things a little bit better, okay? All right, so now that we figured that out, we also need to identify what our y-intercept is going to be. Well, we know our y-intercept here is going to occur at 9. So the reciprocal of 9 is 1/9, right? So if we do the reciprocal, we get 1/9. Therefore, we have a y-intercept right here, almost at 0, but it's a little bit higher. It's at 1/9, okay? So now that I've done that, the next thing that I want to do is identify where my graph is going to be positive. Well, I know that my original graph is positive from -3 to 3, so therefore my new graph will also be positive there because remember, when you take the reciprocal of a positive value, you still get a positive value, okay? We know that our graph is going to be negative everywhere along this area, so therefore the reciprocal will also be negative, okay? We know that our graph right here is going to be negative here, therefore the reciprocal will also be negative in this area right here, okay? So the next thing I want to do is I want to know where is my graph increasing or decreasing. So in this section right here, if my original graph is increasing, then my new graph will be decreasing. So I know everywhere to the left of -3, my graph will be negative and decreasing. Okay, then in this section right here, I know from -3 to 0, my graph is increasing right here. Therefore, my reciprocal function will be decreasing. But I also know my graph is positive. Therefore, my reciprocal function will be positive. Remember, negative, positive, same, increasing, decreasing, opposite. Okay, so over here, my graph here is decreasing, therefore my reciprocal function will increase. But my graph is still positive, so therefore my reciprocal function will be positive. Okay, here my graph is negative, so my reciprocal function will be negative, but it's decreasing, therefore my reciprocal function will be increasing. Okay, that's going to be some really helpful information. The last thing I'm going to do is look and see, well, where is my graph? Where does my graph appear to be to hit 1? Because the reciprocal of 1 is 1. That's nice and easy for me. Okay, so it appears that my graph is going to hit 1 somewhere around here. So if it hits 1 and my original graph here, then my new function will also hit 1 there. Also happens right here as well. Okay, where's my graph going to hit -1? It appears really close to my asymptote right here. Okay, sorry, it should be close to my asymptote over here. Okay, and then this graph right here hits -1 close to my asymptote over here. Now that I've gotten all that information, I can figure out what's happening here. So if it's negative, it's going to stay below my x-axis. And if it's decreasing, then I know my graph is going to end up looking like this. And it's going to try to touch this asymptote, but it just can't. Here, in this section right here, we know that our graph is positive, so it's going to stay above my x-axis, but it's decreasing. So therefore, my graph will end up looking like this. Okay, and it's going to try to touch, it's going to touch 1/9, but it's never going to touch 0. Okay, then in this section right here, my graph is increasing and positive, so it's going to go up like that. It's going to try to touch my asymptote, but it won't. So that's what my new graph right here is going to look like. And then over here, I know my graph is negative, so it's going to stay below the x-axis, and it's increasing. So therefore, my graph will look like this. Okay, let me go over it in orange so you can see it a little bit better and have a little bit of a distinction between the asymptotes and the graph itself. So again, here, my graph is negative and decreasing, so it's going to look as follows. Okay, over here, my graph is positive and decreasing, so it's going to look like this. Then it's going to start increasing again, but stay positive, so that's what my graph will look like right here. And then over here, my graph is negative and increasing, therefore my graph will look like that. And that's how I draw my reciprocal function. So this is going to be g of x equals 1 over 9 minus x squared. Okay, so now let's write out all of our information. We know that our domain is going to be all x values except where my asymptotes occur, and they occur at, sorry about that, they occur at x equals -3, and they occur at x equals 3. Okay, so I know that my asymptotes will happen when x equals -3 and x equals +3, so x can be any real value except for plus or minus 3. Okay, now my range is a little bit trickier. We know that y can be any real value except it will never touch 0. Okay, so it will get really close to 0 but never touch it. So I can say that y is less than 0 over here. But over here, y doesn't even go below 1/9 because 1/9 is our y-intercept, and then our graph starts to increase again. So there are two things that are happening in our range. We know that our y values will never get below 0, and we also know that our y values will be above 1/9. Okay? Where is my graph positive? My graph is going to be positive under the same interval, so from -3 to 3. Where's my graph negative? It's going to be negative under the same interval, so from -∞ to -3, combined with 3 to infinity. Okay, now two more things. Where is my graph increasing? Well, my graph is increasing in this section as well as this section, but we can't include 3 because nothing's happening at 3. So we're going to say it's increasing from 0 to 3, and it's also increasing from 3 to infinity, not including 3. So we would say it's increasing from 0 to 3 and from 3 to infinity. Okay, now where is my graph decreasing? If you notice right here, we figured out it's decreasing in these two areas right here. So it's decreasing from -∞ to 3, to -3, excuse me, and also from -3 to 0. So again, our interval of decrease is going to be from, sorry about that, -∞ to -3, as well as from -3 to 0. Okay, if you have questions, please come with them next time I see you guys in class. Question number 3, with our conclusions that we have here, I want you to see if you can figure out what these conclusions might be, and then actually fill in the blanks, do it with pencil, so that way if you have a mistake, no big deal, you can just always erase it, and then we will compare our answers together next time I see you guys in class. All right, have a good weekend.